I'm Tim Ventura, and we're joined today by Oscar Martin, a strategy, innovation, and transformation executive. Oscar's extensive career includes executive and technical expertise with cutting edge technologies, helping design the early smartphones with Hewlett Packard, designing torpedo stabilizers with BRS Aerospace, developing the video technology used in the Nasdaq building, and leading the development of several subsystems of the Galileo satellites, the European GPS. Oscar has also restructured several companies, including the 22 sites of GKN Aerospace in North America. He's worked in the energy industry with the AKO Group, leading the team designing, manufacturing, and building the electrical control software and hardware for nuclear and solar plants. Our focus today are the challenges and solutions to meeting the world's energy demands. So, Oscar, welcome back, sir. Let me start with this. It's winter, it's cold, and Europe is in an energy crisis from the Ukraine war. They've been investing in renewables like solar and wind for decades, though. What's wrong here?
Well, Europe, 2022 is the energy year. No, we have reconsidered a lot this year, and Europe has been the problem, the war in Ukraine, and well, the problem in Europe has been baking for decades. You know, Europe abandoned the path of cleaning its energy industry by using reliable energy sources such as hydro, geothermal, or nuclear. You know, Sweden, for instance, in the 70s, Sweden and France went for nuclear, and it went really, really well. I can probably share here a picture of how Sweden, France. This is for France.
Oh,
How
wonderful. Thank
it
you.
was able to replace fossil fuels with nuclear energy in a very short amount of time. Something that other technologies cannot do it, and we've seen that new renewables are not able to do it. Other other countries such as Iceland, they went for geothermal. Norway, Austria, they went for hydro, and others use a mix, like Spain, that went for a mix between hydro and nuclear. You know, and those countries are today the countries that are less polluting, and other countries that abandon this path, they went for renewables, and new renewables, not all renewables, but new renewables, solar and wind. They have a problem. They are intermittent. And that intermittency requires a backup power. It's like if you live in an isolated home and you install solar panels or a wind turbine, you need a generator because solar is not active all the time. And same for wind. For instance, here in California, the capacity factor, the amount of energy that they are actually delivering compared to the total potential energy that they could deliver if they were supplying 24/7 is only 26%, about the same for solar and wind here in
Okay.
California.
Well, so let me break in for just a second. For the audience sake, we should be completely upfront about the fact that you are a giant advocate of nuclear power, and I am to some degree also. But one of the reasons that I wanted to have you on is you have been posting repeatedly. We're on LinkedIn together. You've been posting repeatedly on a lot of breakthroughs and, I guess, new trends and paradigms in nuclear power. So that's kind of our focus today. Now, that being said, and you already touched on this, we should be open about the shortcomings of renewables because those seem to have been sold to the public rather disingenuously. I mean, for instance, this idea of solar doesn't work at night, wind power when there's no wind. I think that most people tend to just assume that energy is stored, but it's actually delivered in real time. And from what I understand, if at night or if there's no wind, it actually goes back to a gas-fired plant to make up for the shortcoming, right?
Yeah, that's a huge problem. Well, first, I'm a nuclear advocate, but I'm also a geothermal advocate and hydro advocate. I mean, my focus is on energy sources that meet the three main factors that we want to implement. They must be clean, they must be affordable, and they must be reliable. The problem is, the problem of nuclear is that it's unfair how the society has judged that energy source compared to the potential or others. I mean, that's the big problem of nuclear.
If I could ask for a moment, and and this wasn't in my notes, but so geothermal is something I've been seeing a little bit more about lately, right? I think that's starting to be explored as this energy crisis deepens. Is there real potential there? And if so, do you have any idea why it hasn't been explored more in the past?
There is a huge potential. I mean, worldwide, there is here in the States, there is a huge potential for geothermal. Let me show here the map of the NREL. You can see there is plenty of potential here in the States, and about the same worldwide. This is the percentage of having a proper production plant depending on the area. You can see the West is very good at that. All the rocky area are very good at that. So geothermal has a lot of potential. Here in California, it provides about the same power as wind, but it has been the same for the last 15 years. So no evolution on that technology has been done here in California. And as you can see, Nevada or Idaho, Oregon, they have a lot of potential. So that is another source of energy that the attention has been distracted, and they've been focused on solar and wind, and we have paid less attention to good energy sources such as geothermal.
Yeah, no, and again, looking at this, so the red areas are more favorable. That's where you're going to have a larger heat gradient between what's under the ground and for instance, the atmosphere, or or lakes and rivers to use for cooling. So, in terms of this graph, that those red areas are better and the others are just not as favorable. Now, the other one you mentioned is hydro. I'm in the Seattle area. In the Seattle area, most of our electricity comes from hydro.
Yes.
From what I understand, it's some of the cheapest electricity in the country. A lot of people are setting up like crypto mining and stuff in this area because the cost of electricity is, so much less than other areas. So hydro works, but from what I understand, obviously you need a large river to do it. You need to build a dam, and then there are some, if I understand, there are some physics aspects to that too, in terms of the amount of water drop that's required. So you can't just build dam after dam after dam. You have to basically find a spot, and there are a lot of constraints involved, right?
Yeah, you need a lot of different in altitude, a lot of pressure, and to build pressure, you need the best is to have a narrow and deep valley. That's why, for instance, Norway is so good at that, because they have a lot of valleys that are very narrow, that they could be a very high dam, but not very wide. And then they can generate a lot of power that way.
Yeah.
With a relatively small environmental impact. That is one of the big problems of hydro. It requires a large area, and the environmental impact is huge because you destroy complete valleys on that. So that's why we have to put everything in balance.
Context.
For instance, nuclear, we say no. In case of an accident, that area is destroyed. It's not. but actually hydro destroys it instantly while it's feeding it. So yeah, we have to put everything into perspective, you know.
Yeah. Well, and going back to solar and wind as
Yeah.
renewables, I think that we definitely have a more realistic perspective on these than we've had in the past. So they require petroleum backups. They only supply a small percentage of electricity. The renewable supply chain, this is something most people don't think about, is subsidized by petroleum. So I mean, people are using gas-powered vehicles for maintenance. The wind turbines are manufactured using petroleum-powered products, right? I mean, these are things where the manufacturing and supply chain is mostly petroleum-based that goes into these. And then one thing that I've been seeing a lot more is the environmental lobby is unsatisfied that used turbines and solar cells are starting to pile up in massive landfills.
Yes,
So
that's the problem. The problem of solar and wind is that they are not sustainable. I mean, the energy is sustainable. The sun is there and will be there for 1 billion years, or at least. So the problem is the rest of the life cycle. For instance, one of the biggest problems that you've mentioned is mining, the resources that it requires, and
yeah,
per unit of energy delivered. I can share here this graph. This compares all the main clean energies, and you can see solar, hydro, and wind require a lot of material per unit of energy delivered per terawatt hour. So that is one of the biggest problems is very resource intensive, and this generate pollution. Mining is dirty. We don't see it here because it's done in China, Indonesia, that area, but it's there. It's in the world. I mean, we
yeah.
are polluting the world. It's not the clean energy that solar and wind advocates are selling to us. The other problem is in the operation. As you said, solar and wind, they are not delivering the whole time, so they are intermittent. And the problem is that previously we see before this is a cartoon that illustrates more or less the transition that has been done in the last 20 years. Before we had a power station, a polluting power station that was providing energy. After putting the bird choppers or the solar panels, what we have is that plus the backup power station that remains there. So we are reducing the consumption of fuel, but we are not removing petrol plants. I mean, fossil fuel plants, coal and gas, in most cases. What we are doing is reducing the fuel, but the amount of plants are exactly the same. And the problem is that backup power cannot be a clean source, cannot be nuclear, cannot be geothermal, cannot be hydro. Why? Because geothermal and nuclear, they have a very small variable cost. So that means that if they are producing or they are idling, the cost is going to be the same. So why are we using this? Because this is fossil fuels, because we save on fuel, and fossil fuels are expensive. So that's why there is a huge difference between idling and operating a gas or a coal plant. So that's why the only energy that can provide backup are fossil fuels and not geothermal or nuclear. So that is the big problem of intermittency at this point. Storage could be a solution, but it's so expensive that, remember the three. It has to be clean, affordable, and reliable.
Yeah.
And hey, storage is not affordable. So combining solar and wind plus storage is very, very expensive. In Minnesota, they did a comparison. They wanted to clean up the grid in 18 years. They did two analyses, one using going full nuclear and the other going full renewables. Because they cannot be mixed. That's the problem, that they cannot be mixed.
So Oscar, let me get into the politics of this for a moment. The political left supports renewables because they don't pollute the air, and it's an alternative to the status quo. The political right, from what I understand, tends to support petroleum because it's stable, reliable, and profitable. So who is supporting nuclear and fusion? And I know to some degree, I think to some degree, everyone is supporting fusion. I think to some degree, everyone supports nuclear. Is there a political, I know they have their own lobbies. Is there a side of the spectrum that supports them, or do they tend to be more middle of the road?
Well, first, the biggest problem is not the climate change, it's the pollution. Fossil fuels, they are not only CO2, they are not carbon emitters. They also pollute a lot. Coal pollute a lot, not only the atmosphere, but also the soil, because all the solid ashes that comes from burning coal, they are not only toxic, but also radioactive. And they are stored in open air, in ash coal ponds, or they cover it with soil. But that, with rain, those ashes can go pollute the soil and the groundwater. So those are a lot more dangerous than nuclear or solar panels or any other thing.
Yeah.
So fossil fuels is the worst thing. So we have to change that. Regardless the climate change, yes or no, we have to phase out fossil fuels.
Well, and from what I understand, and even worse than traditional fossil fuels, Germany, for instance, at least for a period of time, went back to coal-fired plants.
It is,
right?
Actually, yeah.
Yeah, and that's a result of this European energy crisis. And so hopefully they're able to find a way forward from there, because coal, that takes me back to like these traditional images of like London, right? In the 19th century. Coal was incredibly dirty. Petroleum was a giant step forward. Petroleum was the clean energy of the day compared to coal. So, so hopefully they can find a way to get off of that, and then they kind of move forward. Yeah, I like geothermal. I know nuclear is one of your big areas. One of the advantages of nuclear, from what I understand, is, in terms of actual waste produced, it's actually much smaller than people would imagine, right?
It's nothing. Consider the new reactors, for instance, the TerraPower, the waste, the fossil fuel waste per megawatt is half a gram per megawatt. So imagine in a 80-year period is a little bit more than 150 grams, 5 ounces of waste. For one person a lifetime is a lot. It's a lot. It's 5 ounces. It's nothing. It's a lot. It's a lot cleaner than what most people think. And if we talk about carbon emissions, taking into account the whole life cycle, that is what advocates of solar and wind usually forget. Nuclear is the cleanest. It's the cleanest. The less carbon emitter in the world. Even the United Nations, in the last study, 2021, you can see that nuclear has the lowest carbon emissions of any other source. So for climate change, nuclear is the best solution. Solar, the life cycle, mining, manufacturing, operation, and disposition, solar emits about 4 to 5 times more carbon dioxide than the life cycle per terawatt hour of energy generated. So nuclear is the cleanest.
Yeah. I think that the biggest obstacle to nuclear is fear, right? I mean, and you know, I have to admit, when Fukushima happened, I was afraid. You know, here again in the Seattle area, one of the worries was that radioactive water was going to cross the Pacific and, you know, have a lot of negative effects. And I think that the reality of it, which is a little bit more balanced, was, you know, obviously it diluted out. We ended up with no issues, but you know, but nuclear is scary for people, right? They think of, I mean, 3 Mile Island. I think that was the first big one. Then Chernobyl, you know, and then obviously Fukushima. And when nuclear accidents happen, even though they're rare, they make headlines everywhere, right? It just gets it, you know, it gets drilled into people's heads. So I think most people are aware that nuclear is clean and it's safe, but I think that they're terrified of those times when it's not safe. Now, you've looked at some different reactor designs. Last time we talked, you were really into molten salt reactors. And from what I understand, those are inherently more safe, aren't they?
Well, any current reactor is safe. I mean, the TMI, the 3 Mile Island accident, that was very, very old. And it was nothing. I mean, it was radiation was released, but people received radiation equivalent to the radiation that anyone received in a flight between LA to New York. Nothing. I mean, nothing. So the 3 Mile Island was a failure, but had no consequences. Nothing. Chernobyl, yeah, it was an accident. It was an old reactor. It was a design from the 50s, and well, it was also, there was a mix of I mean, was horrible, that thing, but not the consequences. It was because it was really, really bad, the consequences. Well, for instance, an accident, any of the 2 accidents of the Boeing 737 caused more deaths than Chernobyl.
Yeah.
And Chernobyl, the area, 1 year after the accident, 1 year in 1987, the radiation was about half the radiation that you can find in the soil of Guarapari in Brazil. A natural radiation that is in that city, and a touristic city. I mean, it's a touristic place. And
well,
there, the
yeah, and if I
high.
could break in, so I think that that's something people aren't aware of. There is a lot of natural radiation. In fact, something else that I recently read, this is unrelated, but there's also natural asbestos. People who live in the West, I believe Las Vegas, but I may be mistaken, there is naturally occurring asbestos in that area. And so, you know, they say that you don't want to have asbestos exposure. There is a small amount in some areas of the United States that happens naturally. Radiation is the same thing. I think that a lot of people have heard about radon gas, right? Radon gas is probably the most well-known naturally occurring radiation source. Now, when you talk about Brazil, you're talking about radiation occurring in mineral deposits in that area, right?
Yeah, in the city, in the beach, the water. I mean, the radiation level was twice the amount than Chernobyl 1 year after the accident. So 1 year after the accident, the area was less radioactive than a city. I mean, so and today it's about 1/10 the radioactivity of the radiation of Guarapari. Anyone living in a stone house or that has a granite countertops or marble floors, rocks are radioactive, all of them. So, I mean, radioactivity is everywhere. A banana is very radioactive because it has a lot of potassium that is very radioactive. So, I mean, the problem is that people hear about radiation and they believe that it's something bad. Well, it's as bad as fire. Fire can burn you if you touch it, if you are too close. If you are too far, you die because you are cold. So,
you know, I think a lot of this comes out of the Cold War, right? And you know, you have those movies like the Day After. You know, you had a lot of this post-apocalyptic mentality in the 80s, a lot of fear and uncertainty about nuclear war, and then there was this, you know, this idea of if the war happens, if the big one happens, you know, for instance, you have to take iodine pills, you know, to prevent the radioactivity from damaging your thyroid. You know, there are all sorts of issues there, I guess. And I think that has provoked a lot of fear in people, and that carries over to the nuclear industry.
Yeah, and for instance, in Fukushima, about I don't know how many thousands, I don't remember exactly, but many thousands of people died in the evacuation caused by fear. No one died because of the radiation. So we are talking about the Fukushima disaster, but the actual disaster of Fukushima was the fear. The fear killed more people in Fukushima and around the world. I mean, by not using nuclear and using coal, Germany is killing people. It's killing their people by burning coal. Because coal is radioactive, it provokes cancer, and you breathe it, you drink it in the water. So yeah. I mean, we are. I compare nuclear to aviation. It's the safest transportation in the world. A lot more than ships or cars or motorcycles, but there are still people afraid of taking a plane, taking a flight, and a huge more people fearing nuclear, when actually nuclear is the safest energy source that we can have.
Now, if I can, and again, I'm trying to think back to Fukushima, but I think another fear that people have is like when companies cut corners, right? Especially with nuclear, there are established safety standards. There are a lot of them in place. As I recall, with Fukushima, some of those standards were a little bit outdated, and again, I'm very fuzzy on this. I also remember reading something about corners being cut that helped lead to the accident, right? And that was on a corporate level, and so everything, you know, things were done correctly, but by the lowest bidder or something along those lines.
Yeah, the problem of Fukushima was that plant was very old, very old. New plants, any plant built in the last 36 years cannot have that accident. And the problem of Fukushima is that they did that plant was not updated to fix that problem. Fukushima, the reactor was working fine. It shut down properly. It never had any risk. The reactor didn't explode at all because current reactors cannot explode at all. They are not. The new designs are very different. I mean, there are many different nuclear reactors. It's like cars. You can have a diesel car, a gasoline car, a liquefied gas car. You can have electric battery car. You can have a fuel cell car. You can even have an air compressed car. So and all of those are completely different technologies, but they are all cars. Well, for nuclear plants, we have the same. We have many different designs, many different concepts that they use very different approaches. Well, the safety measures, they have to be different for each of them. So current reactors are completely different to the reactors of the past, and the safety systems, they have evolved. Fukushima did not update the safety measures for the used fuel pool.
That was what I was remembering. Yeah.
Yeah. So when the water started boiling because the cooling system was not working, it doesn't matter if it's boiling. The problem is that hydrogen built up in the building, and if you don't have a relief system, the pressure build up and the roof pops up.
Yeah.
That's what happened at Fukushima. But there wasn't any outstanding amount of radiation release everywhere. Then they use a lot of water to cool down that. That is the water that now is considered a problem. And that area is very small. Actually, it's comparable to the area here in San Obispo in California. There was a huge oil tank farm with a lot of large oil tanks. Well, a lightning strike, and 4 of those tanks exploded.
Okay.
And started burning, and there was oil spill everywhere. So the area that is about the same size of Fukushima is still today, 100 years later, because it happened in 1926. About 1 century later, is still contaminated.
Yeah.
It's not like Chernobyl, that 1 year after that, the radiation was like natural levels found elsewhere. And today, Chernobyl is a natural reserve. I mean, there is no problem in Chernobyl, and you can visit that without. You can even visit the plant right now, today, for $150. Well, not today, since February. Not that is closed because of the war, obviously, but not because of the radiation. So it's a touristic place. It's a natural place. And that happened only 36 years ago. Imagine the oil spill happened 1 century ago almost, and it's still contaminated.
Well, so let me ask, in terms of nuclear, so it sounds like probably the best path, just looking at all the different numbers, putting fear aside, when you look at the numbers, it sounds like the best approach may be nuclear. And then obviously, I think everybody wants fusion after that, right? Now, do you have any thoughts on how far away? I mean, they just had that big breakthrough. I believe they put 2.05 megajoules into the laser system, and they produced 3.05 megajoules of fusion. And that was the National Ignition Facility, if I remember right. So they were saying that was a giant breakthrough, but it was only for a split second. And they're still saying fusion may be a couple of decades away, right? The 2030s, maybe farther.
Yes. I mean, the problem of fusion, what made it always the promise of 20 years ahead, was the tokamak. I mean, there are different ways to achieve fusion. Basically, you need to put everything together. I mean, to have a lot of pressure, to put the atoms very close together, have a lot of energy inside, then you can break the Coulomb barrier and release a huge amount of energy. We know it happens. I mean, fusion happens in the sun. Fusion happens in the H-bomb, in nuclear bombs. They are, most of the energy release comes from fusion, not from fission.
Well, yeah, and one thing hobbyists build are tabletop fusers. Most people aren't aware of that, but the inertial electrostatic confinement IEC fusers, that's something that hobbyists have actually built on their table. They produce actual fusion. They just don't do it in useful amounts. They're so far below the input energy that there's no way you could get energy out.
I mean, fusion happens, and we know that positive fusion is physically possible, but because we've already done it. I mean, in nuclear bombs, I mean, all the nuclear weapons that are now, not the one from the Second World War, but today, they use not just plutonium or high enriched uranium to detonate. The huge amount, I mean, the most of the amount of energy released comes from fusion. That's why it's called the H bomb, the hydrogen bomb, because we use uranium and plutonium only to ignite the fusion. So the problem is how we can control that to be in a controlled fashion and not as a bomb. And that's the problem. The problem that tokamaks try to solve using a magnetic field to maintain, to squeeze the plasma, the hydrogen plasma, the proton plasma to be together. The problem is that it requires a lot of energy. Superconducting magnets is huge. Look at the ITER.
They are, yes. They're massive
huge,
facilities.
It's very expensive. So in the last couple decades, other approaches have came out that are called inertial confinement. Instead of magnetic, is inertial. Inertial using from pistons, like General Energy is trying to do, to lasers. That is what the National Ignition Facility is doing. There are other ways, but inertial has achieved more results than magnetic in a shorter amount of time. So that's why today we're thinking that that path is gonna reach the goal faster than what we've been doing in the last 60 years.
Yeah.
Here in San Diego, we have a tokamak too, smaller one, the D3D, and there are others. But we're still far from that. I mean, this news that came out last week, a couple of weeks ago, it's interesting because they've solved the problem of fusion more or less, because they are delivering 53% more energy out than the energy required in. But those lasers that are putting that energy inside the reactor require about 400 more energy to light up. So the problem is that the efficiency of those lasers are terrible. They are very, very bad. So we cannot, I mean, we're still far from achieving positive energy. But we're still far, but we're in the right track. It's the right the right path. Inertial confinement seems to be the right way to achieve fusion in a controlled way.
So to kind of wrap things up for today, then, geothermal, that's something that you like. Hydro, that's something that you like. Those are both conditional, right? Those are conditional. They're geothermal depends on the region that you're in. Hydro depends on, obviously the availability of the rivers as well as the drop required to take it out. Both of those do have some environmental impact. Nuclear, that's something that you are a giant advocate for and can, have been and continue to be. And then our hope is, over time, we can transition to fusion, maybe in 20 years, something. I've read the 2030s. I've also heard 20 years. The joke has been that no matter when you ask, it's always 20 years away.
20
right?
years away.
Yeah. So.
Yeah, I would say that we are probably 10 years away today.
That's
in
not
the
bad.
30s. I think that the 2030s is going to be the fusion revolution. But we don't have it yet. We cannot bet or wait doing nothing until we have fusion, because we have fission. And nuclear fission, it's clean, it's affordable, it's not as expensive as people think. I mean, it's expensive here because here we place in the States a huge red tape that costs a lot of money to overcome. So that's why here in the US, even US startups, they are executing their projects in Canada or in Europe or in China. China is advancing a lot on that because they don't have that fear. Everything has. I mean, they are very pragmatic. They are
I was going
practical
to say
people,
pragmatic.
and they are building it. They are building it at an very affordable cost. They are building it in a very affordable time frame. They are doing all of them at the same time. I mean, they are demonstrating to the world that the revolution in the 70s is possible today too. So there is no reason to stop building nuclear plants other than fear. And fear comes from the misconception of nuclear, because nuclear, in case of an accident, it has way less impact than an oil spill. It has way less impact than than solar and wind through the life cycle. I mean, it's so far is the best, along with geothermal, for their small footprint, for the reduced amount of resources required to produce, and for the long amount of time that it can be producing. Because solar and wind, you invest a lot of money, but you will need to reinvest the same in about 15, 20 years, because the lifetime of a turbine or a solar panel is very short. A nuclear plant can last 80 years, and even the AII Grassi told about 1 month ago that there isn't any reason for them not to achieve 100 years. Hydro plants, they are the more than 100 years, 120 years, and they are still producing. Obviously, you need to maintain the turbines, because corrosion happens, it's natural, and you need to maintain that corrosion that is happening in the pipes, turbines. You need to replace, you need to maintain. But
those seem to be more of known values, though, right? That's pretty traditional mechanical maintenance, and so
But it's everywhere. I mean, maintenance is everywhere. In your car, you need to maintain your car. So for any machine to be properly maintained, you need attention. That is what France had problem with, because they followed the German policy. They even committed to reduce nuclear to 50%, which was really a suicide. So far, Macron has seems to change that, and it's Europe is, I mean, at least France and Sweden, they are again pushing for nuclear, but there's still the resistance of
and I should mention that
Germany, Spain.
I'm not sure if it was France or Germany, but I remember reading about one of the European countries had decommissioned 2 nuclear plants. They're actually looking at bringing those back online. There was a third, and I believe this was Germany, but I may be mistaken.
Germany.
This was, and there was a third that was scheduled to be decommissioned, and they've decided to keep it in service.
Yeah, the problem is that Germany today, they have 6 plants, 6 nuclear plants that they are certified. If they are fuel, they will be producing. But Germany decided to turn on coal plants instead of turning on nuclear plants that they are certified. They are operative.
Yeah, and I believe a lot of that was just, again, being pragmatic and expediency because of the energy crisis. And the hope is that once they have a little bit of time to do things the right way, then they'll be able to kind of get things a little bit more organized, right? So,
yes.
Well, Oscar, on that note, let me thank you so much for your time today. It has been a true pleasure and an honor, as always. And I always look forward to having you on. I would love to have you back on in the future as well, sir.
Yeah, it's always a pleasure being with you here, Tim. Anytime.
Thank you again.